Okay, so we're going to talk about how we measure how much modulation has occurred. To do that, we need a quantity that we call the depth of modulation. It's called the depth of modulation. As you can see, this one has got a much higher modulation, so it's much deeper. The carrier amplitude in each case is 8 volts. So in both of these cases, that's 8 volts. Obviously, the first one has much less modulation than the second one. Notice this is 2 volts, which makes sense because we're going 2 volts above and 2 volts below. So that's the 2 volts either side of the carrier amplitude. And this one is 6 volts, so 6 volts below, 6 volts above. And we can take this even further. So this is called 100% modulated because it's going from 16 all the way down to 0. Again, 8 is the middle. And this is called 100% modulation. This can be a bit of an issue around here, but if your frequency is high, it's not necessarily a big deal. However, if you over-modulate it, this becomes an issue. So this is 10 volts. So 10 volts up. But it's also 10 volts down. So 8 minus 10 is minus 2. This causes issues because you get this crossover region, and that's kind of a distorted, mangled bit of signal. So that's not good. So how do we measure the depth of modulation? Well, if we increase the information amplitude, as we've seen from these 4 graphs, we increase the depth of modulation. However, if we increase the carrier amplitude, then it has less of an impact. The higher the carrier amplitude, the less the depth is modulated. So this brings us to the equation that the depth of modulation is equal to the information amplitude divided by the carrier amplitude, and we times by 100 to turn it into a percentage. Make sure you label this on your datasheet. Okay, I'm going to talk about the second equation. I'm going to show you where it comes from. So this is called Vmax, that's the maximum voltage, and this is called Vmin, because it's the minimum voltage of this envelope. So if it's being enveloped by the sine wave, that's the minimum voltage. If we want to work out the information amplitude, then we need to work out what half this is. So that is Vmax minus Vmin, but we want half of it because we don't want to go peak to peak, we just want half of that. Now, if we want the carrier amplitude, we want in the middle of these two values. And the middle of the two values is the average. You add them up and divide by 2. So if we want the depth of modulation, we take these values and we divide them. So this divided by this, which means the same as this divided by this. And we remember, of course, we write depths of modulations as percentages. So you're going to times by 100 to a percentage. Now the 2 will cancel. So the depth of modulation is the difference over the sum, and then timesing by 100 to turn into a percentage. So that brings us to the second equation, which is exactly the same equation, but it's much better and easier to use than if you've got the graph. And it actually does the calculations of the information amplitude, carrier amplitude for you without you having to do like an extra 3 steps instead of 1 step. Okay, let's have a look at some examples. I would recommend that you pause the video and you have a go at these questions before I do them. Okay, first question. So this is definitely a case where they're giving you the numbers and you stick it in. And the first equation, definitely the sensible one to use here. So that's 2 volts over 8 volts times 100. So 2 over 8 is a quarter of 100 is 25. So the depth of modulation there is 25% at the lower end. Okay, let's have a look through the graphs. So Vmax, so I'm going to go through those 4 graphs. So Vmax in this case is 10 volts. Vmin is 6 volts. And we've got them in the equation. So the difference divided by the sum. So it's 10 plus 6 over 10 minus 6 times 100. So that's 16 over 4. 16 over 4 is... Sorry, got my plus and minus the wrong way around there. Say that again. Sorry, 10 minus 6 is 4. 4 divided by 16 is a quarter. A quarter of 100 is 25%, which is exactly the same as the previous one. And you can see why that's true, because this is the middle, and this is 8 volts, and we are going up 2 volts, so that's the information amplitude. So that's also 25%, but you could be asked in this form with just the numbers, or you could be asked to work it out from the graph. I think it's easier to just stick it in the equation, but you can work out the information and the carry amplitudes and put it in the other equation. Let's have a look at the second graph again. I would encourage you to pause the video, have a go at this question yourself before I do. I'm going to go through 5 questions. That's the third of 5. So Vmax is 14 volts. Vmin. We like Vmax and Vmin, practically speaking, because they're pretty easy to measure and easy to tell a machine how to measure. So this is also a very practical way of doing it. Again, you're just bringing the numbers in the equation. So it's the difference over the sum. So that's 12 over 16 times 100. Sorry, it's a percentage. 12 over 16 is the same as 3 over 4 times 100 is 75%. So this is obviously a lot higher than the previous one. It's 25%, 75%, and you can see that clearly on the graph. Again, pause, have a go at this one yourself. Okay, let's have a look. So again, same process every time. Vmax is 16 volts. Vmin in this case is 0. So we've got the difference, 16 minus 0 over the sum, but 0 plus or minus 0 is the same. So we've got 16 over 16, which is 1 times 100 is 100%. So this is why we call this 100% modulate depth of modulation. So last one. Let's have a look at the over-modulated one. Again, I would encourage you to pause, have a go at this yourself. Okay. Again, same process. So Vmax in this case is 18 volts. Vmin, now this is where people get caught out. Make sure that you are following. They've done them in different colors. They won't necessarily do that in the exam. If they give you an over-modulated one, which they usually don't. But if they do, make sure that you've traced out one wave on top of it so you can see. So this is Vmin and it is negative. So this is minus 2 volts. So this is where it's a little bit different. So again, it's the difference, 18 minus 2 over the sum, 18 plus minus 2 times 100. So that is 20 over 16 times 100. If Put that in your calculator and you'll find that it's 125%. So this is definitely overmodulated. This is a problem and a graph you don't want to see if you're designing a system. Okay, that's it for depth of modulation. Do make sure that you're comfortable deriving it from the different types of graphs. You could be asked to draw the graph given a certain depth of modulation and given all of the values. So let's say that you are given the carrier frequency amplitude and you're given the depth of modulation and asked to draw it, in which case you would take the equation m equals AI over AC times by 100 and rearrange that to make AI or AC the subject so that you can work it out and then you can sketch it on the graph. That's it.